Spiders can form colonies in toxic sulfuric acid caves, use webs as gigantic artificial eardrums, and even dream. From their origin in the Jurassic Period all the way to the modern day, they've proved to be successful, adaptable predators across 6 continents and countless lifestyles. We're going to cover the basic evolutionary history of spiders, highlighting some rockstar taxa from the fossil record and modern day, as well as dive into the physiological adaptations that have led to such an incredible and consistent track record. What is a spider anyway? The anatomical definition is an arachnid with 8 paired limbs, a prosoma or cephalothorax joined to an opisthothoma or abdomen, and the ability to spin silk. These animals are in the order Araneae, a clade that contains over 53,000 different species. Let's first go over some of the main groups within the order in an evolutionary highlight reel before discussing physiological factors that have led to spider success. The first anatomically modern spiders are thought to have evolved between 375 and 328 million years ago according to a 2020 study, either in the late Devonian or early Carboniferous. Sister groups to spiders continued to thrive for a long time, with one recent discovery, Chimera Araneae, being similar overall but bearing a long tail. Mesotheliae spiders have fangs that aim directly downwards, as well as 4 pairs of spinnerets on the underside of their abdomen, setting them apart from other spiders. They use silk trap lines in order to detect prey outside of their burrows and then seize them in an ambush, overpowering them before they can escape. The rest of spiders belong to the clade Opisthothelae, which can have 1 to 3 pairs of spinnerets at the back of the abdomen. There are 2 main groups in this clade, the megalomorphs and the araneomorphs. Megalomorphs bite straight down like Mesothelae and include some famous and charismatic taxa. Megalomorphs are the big gun spiders like trapdoor spiders and tarantulas. They tend to be robustly built with large fangs, using physical strength to take down prey that can be their own size or even larger. The Goliath bird eater, the largest spider in the world, is a megalomorph. These spiders can live for a long time as well, with the oldest recorded spider being a trapdoor spider that died at the ripe old age of 43 years. They typically use silk to cover their burrows rather than in prey capture. Araneomorphs bite at a diagonal angle towards the center, rather than straight down, and take silk usage to an entirely different level. Their species count is also absurd. They include the pale, cave-dwelling leptinetids, the tube-spinning philostatids, lampshade-weaving hypochelids, and the palpamanoid assassin spiders. Pause to appreciate how incredibly bizarre these long-necked spider specialists are. They looked at mantids and weevils and said, yeah, I want to do that. The rest of the araneomorphs are inside the clade Intelliginae, like your favorites. Jumping spiders, the geniuses of the spider world. Crab spiders, masters of disguise that spring ambushes inside of flowers and other inconvenient locations. Orb weavers, who have a rich fossil record going back to the Jurassic period. And black widows, wandering spiders, etc. Now that you have a basic idea of spider relationships, let's discuss their adaptations for success, starting with venom. Not all spiders need venom to thrive. One family of intelligents, the Uloborids, actually have lost their venom glands entirely and digest their prey by vomiting digestive enzymes onto them. But for most, venom is key to how spiders hunt and eat. There are 2 types of venom, with severity varying with the species. The first is necrotic venom, which directly causes tissue degradation. Brown recluses are the most well-known example of this venom type. The second is neurotoxic venom, which causes damage to the nervous system. Black widows and Brazilian wandering spiders use this category of venom. Very few spiders have medically significant venom in relation to humans, but it's certainly efficient enough to work on their prey, killing the animals they want to eat and liquefying their insides with digestive enzymes. Here's some more info from my dad, aka Aquarimax Pets.
Notice the straight up and down movement of the chelicerae in this Chaco golden knee as it manipulates the beetle larva that it has just captured and envenomated.
Venom plays an important role in digesting prey, but it isn't always the primary method of capture. Ogre-faced net-casting spiders build a frame web, within which they construct a net that they will lunge with to capture prey. These nocturnal ambush predators can detect the sounds of flying prey animals as well as sense those approaching on the ground, striking with lethal speed to wrap up victims in their net. Their incredible eyesight is how they take out ground-walking prey, but they rely on sound for airborne victims. It may also prove to be a predator avoidance strategy, as they're sensitive to the frequencies that their natural predators, birds, use to sing at. Large ground-hunting spiders use a combination of speed and power to take down prey. Wolf spiders are the classic example of this tactic being successfully used, with their large fangs and lightning reflexes. Nephosids, or true ground spiders, chase down prey and then tangle them up in silk before delivering the killing blow. How about spidey senses? The sensory unit for a spider is a hair-like structure called a sensillum, with multiple types that correspond to a different purpose. Some detect vibrations, others pick up and interpret chemicals, and others sense factors like temperature and even the water content of the air. The percentage of different types of sensilla on a given spider depends on what it needs to hunt. Web-spinning spiders, like orb weavers, specialize in mechanoreceptive sensillae called trichobothria that tell them where prey is within their web. Ground-hunting spiders, like wolf spiders, specialize less in mechanoreception and more in vision, since they often chase their prey down, but still use mechanoreceptive sensilla in order to coordinate their own movements relative to their body. Proprioceptive trichobothria like these are found in all spiders. Nelson 2025 argues that a spider's web acts similarly to how a computer works for humans. It's an extension of the senses and of sensory capacity, functioning as a second mechanical brain in terms of raw input. An example of this is how orb weaver spiders turn their webs into gigantic eardrums, outsourcing their hearing to biologically produced tools.
Tarantulas may not use the web in quite the same way as, say, an orb weaver does to capture prey, but the web is definitely used to help them detect vibrations of prey items in the vicinity of their hides, as you can see here.
Shamble et al. 2016 found that jumping spiders, Phidippus audax, respond to and neurologically interpret sound from over 3 meters away. Part of how they may be able to do this lies in their leg hairs, which are highly sensitive to vibrations. They were especially sensitive to frequencies in the 80 to 130 Hz range, which corresponds to the sounds emitted by flying wasps that naturally prey upon them. Male orb weavers smell with their legs in order to detect female pheromones indicating readiness to mate. It was thought that taste and smell may use the same sensory pores in spiders until very recently, when it was demonstrated that olfactory sensilla do exist on their own. They can use both tactile and olfactory sensilla to pick up pheromones from other spiders, especially from silk deposits. Silk lines can be deposition sites for pheromones both for male and female spiders to signal interest in mating. Smaller spiders will also use silk from larger spiders as a warning, and attempt to avoid hunting in that area for their own protection. Spiders can detect natural levels of electrostatic fields, as shown in a 2018 experiment. The spiders were isolated from any wind or airflow as well as outside electrical activity, and when given an artificially generated electrostatic charge, began to engage in ballooning behavior or tiptoeing, raising their legs and torsos and releasing drag lines of silk. They were able to become airborne when the charge reached a certain level, and sank again when the charge was removed. Wild spiders would most likely use a combination of natural drag forces from the breeze along with atmospheric charges in order to balloon, which lets them move hundreds of miles. Ballooning is a behavior that has allowed spiders to spread across continents separated by entire oceans, something most land animals would struggle to accomplish. It's no surprise then that the ability has evolved multiple times throughout the lineage of these beloved arachnids. It's common in linnifids and araneaes, among other families. Jumping spiders have excellent vision. Many other lineages only care about movement and light or dark, without significant investment in color differentiation. Salticids, however, can identify specific prey types from limited information in a split second and with a 360-degree visual range.
Hey everybody, this is Ergo the Magnificent, a young Phidippus carneus from Bugs in Cyberspace, captive bred. It's molted twice in my care, and has proven to be pretty relaxed about handling after a little bit of time. Gorgeous color, look at that color. Every molt has looked a little bit different, and the carneus often have a little white marking up near the, right behind the cephalothorax actually, and we'll see whether or not that happens with this particular individual, but I'm really enjoying Ergo the Magnificent, so thanks to Peter and Kelsey from Bugs in Cyberspace for sending me this little beauty.
A 2016 study found that jumping spiders can learn to avoid specific colors of prey if that color has been previously associated with a negative taste. Ground hunting spiders, like wolf spiders, tend to have excellent night vision, allowing them to move quickly to obtain prey. But you have to use it or lose it. Multiple lineages of cave spiders have evolved away their eyes. They seem to be happy enough though, so maybe that's the key to happy living. A humble cave of your own where you can evolve blindness in. Rather than having expandable soft lungs oxygenated by a throat system like invertebrates, spiders have two entirely separate ways of engaging in gas exchange. Book lungs are layers of respiratory tissue that allow for passive gas exchange. Spiders use a combination of book lungs and tracheae, or internal tubes that funnel oxygen from tiny spiracles in their abdomen, that allow for oxygenation of their internal systems. Diving bell spiders bring their air with them, creating bubbles of air around their torsos when going underwater to hunt. The bubbles allow carbon dioxide to leave and oxygen to enter while remaining entirely waterproof.
Why is it that so many people are uncomfortable with mini spiders but find that jumping spiders are cute? It may have to do with the fact that they'll interact with humans readily. It may have to do with their large forward-facing eyes, which is part of the reason they make such excellent hunters. But don't let their cute and fluffy faces fool you. They're extremely capable predators. Based on the size and type of prey, they're capable of planning their attacks for a most efficient kill.
As stated in Nelson 2025, knowledge of spider behavior over the past 3 decades has fundamentally overturned previously held assumptions that spiders are rigid, instinct-driven animals with limited cognitive capacity. Indeed, spiders are now often considered among the best animals with which to explore topics pertaining to cognition, including multimodal integration, decision-making, and even learning and numerical competence. Cognition is gathering information and making decisions, paraphrased from Shuttleworth 2000, something we absolutely do see in spiders, especially jumping spiders. You've likely noticed that jumping spiders have received quite a few highlights in this video. That's because jumping spiders are perfect angels, and are exceptional even in a clade of exceptional successes. For example, Avarcha culicivora juveniles, which are smaller and weaker than the adults and less adapted to grappling their prey, will approach different species of mosquitoes with unique hunting postures depending on the species they're trying to hunt. The juveniles will sneak up behind the mosquitoes in order to gain an advantage during the predation attempt, while adults simply overpower them with sheer strength. Portia hunts other spiders by tricking them into approaching parts of their web, essentially trolling them into leaving the safety of their web center. They experiment with different ways to strum the intended victim's web in a way that doesn't cause excessive aggression in order to keep themselves safe. They also have the ability to count to 2, as shown in a 2012 study. Here's an excerpt from Nelson 2025 explaining that study's results. When hunting, juvenile P. africana sometimes sit and wait, settle, in groups outside the nests of prey spiders until the prey spider enters or exits when it is pounced on. The decision to settle is based on several factors, including the number of conspecifics already there. Tests using lures made from 1 to 3 dead individuals of 1.5 and 3 mm long juveniles of P. africana already settled by a nest show that live juveniles of P. africana can represent small numbers independent of the volume of P. africana stuff settled by a nest, as they prefer to settle by a nest when only a single other P. africana is present, irrespective of its size. These tests reveal that they can distinguish between 1 and 2, with 3 possibly being simply too many. Jumping spiders may even experience some form of REM sleep, potentially suggesting a dream state. Avarcha arcuata engages in long periods of rest, during which high bursts of retinal movement along with twitching limbs are observed. What do spiders dream about, and what role does it serve in their cognitive reorganization during sleep? That is a question that further research needs to answer, for my own curiosity if nothing else. Spiders have also adapted to live in and move between a wide range of environments. The one I mentioned at the beginning of the video is one of the most extreme examples. Sulfuric cave spiders living communally at the border of Greece and Albania. A 2024 paper described 2 species of spiders that normally have a predator-prey relationship. Prinerogon vagans, the prey, and Tegenaria domestica, the predator. They lived in a 97 square meter web in a cave full of gaseous hydrogen sulfide, eating larvae of microbe-hunting inverts. On the other extreme, flowers, beautiful, pleasantly scented, and totally 100% innocent all the time, can make phenomenal habitats for ambush predators. Crab spiders, or thomisids, are masters of the craft. They will wait inside of flowers for weeks, slowly changing their color to match their chosen home, and snatch up pollinators when mealtime comes around. Some species of thomicid even mimic ants, or bird droppings. They don't have a monopoly on clever disguises, though. Leaf-mimicking spiders of the genus Aerovixia are also brilliant mimics, able to twist and turn into a variety of shapes to hide from predators and potential prey. The genus Pultis takes it one step further, with a chitinous protuberance that resembles the stem of a leaf. It hangs from branches while disguised and is so good at what it does that we've only found 2 specimens since it was discovered a decade ago. It makes you wonder what else is hiding out there. Or hiding in your walls. Just say it. You may find them creepy, you may find them cute, but there's no denying that spiders are absolutely amazing animals. Their small size, incredible adaptability, underrated cognitive abilities, and flexible diets made them able to weather mass extinction after mass extinction, always finding a niche to call their own in the rebuilding process. and that's my case for why spiders are nature's favorite animals. If you enjoyed this breakdown of cladistics and physiology, you might enjoy the previous episodes on crocodiles and sharks, or rather pseudosuchians and elasmobranchs. Crocodiles and sharks work a little better for search engine optimization. As an invertebrate fan, you'll enjoy Aquarimax Pets. My dad has been running his invert pet care channel for over a decade, and he's even done collabs with Clint's Reptiles. Go! Head on over! What are you still doing here? The movie's over. Well, if you're still here, you can watch the other collab we did specifically about prehistoric invertebrates. I'm the Vividen, and I'll see you the next time I try to trick you into enjoying exposure therapy.